Good morning, students, and welcome to this topic, climatic control factors. Now we shall discuss the topic under various subtopics, starting with air masses. An air mass is a large body of air of considerable depth that is relatively homogeneous in terms of temperature and moisture. The general circulation of the atmosphere produces in certain places large masses of air with characteristic and well-defined physical conditions, especially of temperature and humidity. The sources of air masses are the great permanent or semi-permanent high pressure zones of the earth circulation. Conversely, areas of low pressure are regions of convergent air masses. Therefore, the chief seats of high-pressure cells and therefore the main sources of uniform air masses are the polar regions, the cold continental masses of Eurasia and North America in winter, the host latitude high-pressure cells, especially over the oceans in summer, but to a less extent over such large land masses as North Africa and Australia in winter. Air masses may therefore be described as the polar or tropical, which in general determines their temperature conditions and through temperature, their capacity for moisture holding. Another one is continental or maritime, which in general determines the extent to which their moisture capacity is realized, that is, their relative humidity. The above categorization identifies four individual kinds of air masses, which are tropical maritime, polar maritime, tropical continental, as well as the polar continental. The convergence of air masses in fronts. The migration of air masses from the source must result eventually in their meeting and interference, and this will occur in regions of low pressure, which by their very nature must be regions of convergence. Experience shows that although there are inevitably some marginal mixing and incorporation, the air masses tend to retain the individual characteristics fairly clearly defined, especially in the upper air, which is less disturbed by the turbulence that affects the lower strata in contact with the Earth's surface. The convergence results in the displacement from the surface of the light and warmer air by the denser and colder air, and this ascent produces condensation and precipitation. The severity of the disturbance that accompanies this convergence is proportional to the contrast of temperature and humidity of the air masses involved. For the temperature, contrast provides the main source of energy for the generation of storms. Storminess is greatness where polar air meets tropical, and it does along the polar fronts, and much less where tropical meets tropical along the equatorial front. And now frontal systems. Frontal systems occur all over the world and in all seasons. They are the chief cause of rapid, large-scale changes in weather conditions. When differing air masses meet, a boundary line or front forms. The process is known as frontogenesis. When the front breaks down, the air mixes and the front disappears. The process is known as frontolysis. The types of fronts. We have the warm fronts, which occurs when a mass of warm air encounters a mass of cold air. We have a warm front. The warm air, which is light and less dense, pushes up in a wedge. Pardon. The warm air, which is lighter and less dense, pushes up in a wedge, like formation atop the mass of cold air. However, the slope formed by the upward moving mass of warm air with the horizontal surface is on the order of about 1 to 300. That is, the upward rise would be about 1 kilometer for every 300 kilometers of horizontal surface. Another type of front, we have cold fronts, which occurs when the north brings cold air towards the band of warm air. The heavier, denser cold air pushes in under the warm air and rapidly forces it upward at a sharp angle. This is why a cold front forms a much steeper wedge than a warm front. In cold fronts, the ratio between the ascent of air and the horizontal surface is on the order of about 1 to 50. That is 1 kilometer vertical rise for every 50 kilometers of horizontal surface. We have stationary phones. Stationary phones are formed when a control system stops moving forward. Stationary phones may result from the stalling of either a cold or warm front and may remain stationary for several days. When a stationary front starts to move again, it may be either a warm front or a cold one. The discontinuity of the temperatures often weakens than the front simply dissipates. In a stationary front, the weather conditions are fair and stable. Yeah. We also have occluded front. So occluded fronts are found when cold frontal system overtakes a warm frontal system and two fronts trap air between them that is much warmer than the surrounding masses of air. Occlusion takes place when a mass of warm air is pushed upwards and removed from the ground by two dense masses of cold air. These air masses meet and push the warmer mass of air off the ground surface between them. In a cold front occlusion, a warm front is pushed off the ground by the advancing very heavy air. Let's talk about latitude. Latitude influences the global radiation receipts of the Earth's surface. This affects the Earth's temperature distribution. Latitude also influences the pressure pattern, which in turn determines wind flow and precipitation distribution. Within the equatorial zone, that is 10 degrees north and south latitude, the sun throughout the year provides intense insolation, while day and night are of roughly equal duration. Around the tropics of Cancer and Capricorn, and the North Tropical Zone and South Tropical Zone, respectively, spanning the latitude belts 10 degrees to 25 degrees north and south. In this zone, the sun is overhead at one solstice, thus a marked seasonal cycle exists, but is combined with a potentially large annual insolation. Land and water masses. Before that, let's look at altitude. That is latitude, let's now look at altitude. Altitude, apart from its effects on temperature, decrease of temperature with altitude at an average rate of 6.5 degrees centigrade per kilometer. Altitude also causes changes in pressure and rainfall. Pressure decreases with altitude at the rate of 1 mb per 10 meters. This is up to about 1,500 meters above sea level, after which the rate is reduced until 4,500 meters above the sea level. When the rate of decrease is only 1 mb per centimeters, orographic rainfall is brought about as a result of rise of moist sudden winds over mountain valley. And now land and water masses, as stated earlier, land surfaces are rapidly and intensely heated under the sun's rays, whereas water surfaces are really slowly and moderately heated. On the other hand, land surfaces cool off more rapidly and reach much lower temperatures than water surfaces. When solar radiation is cut off, temperature contrasts are therefore great over land areas, but only moderate over water areas. The relief features. In addition to the effects that mountains have their own climates, they also affect large areas on the leeward side. The ocean basins may have the ocean basins have a lot of climatic influence on their coastal strips than farther inland. Not only is the rainfall reduced in the rain shadow areas inland, but also temperatures are more extreme. And that marks the end of our lesson today. See you next time.